Hey guys, today's lesson is about proving that triangles are using this method. So, some things we can look at. Student objectives for today. Use side, side, side to actually prove, like I said, geometrically that two triangles are congruent. So, last pod we talked about the side, 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 and we pointed out triangles that we could have proved were congruent because they all have the same sides, but we never actually did. So that's what we're going to learn about in this lesson. We're also going to learn how to use CP/CTC to do that same thing, and how to use them in that theorem in proofs. So essential questions for this lesson: how do we use side, side, side? And how do we use CP/CTC? And below you can see the Common Core standards. So what is SSS? Well, SSS stands for side, side, side. And it's the side, side, sides postulate, or the congruence test is another way people identify it. Is used when can be used when all three sides of a triangle are congruent to the corresponding sides, and that's important. They have to be the corresponding sides of another triangle. When this happens, we can see that the two triangles are congruent. And again, this is called a postulate because it can't be proven using geometrical proof, but it is just known by everyone to be true. It can't be disputed, it just can't be proven. Another word for that is axiom. Okay, so let's start off with this proof. Now, just a reminder, when we're doing proofs, we want to make sure that we have two things. That's a column where we are going to make a statement, and that's right here. You see that right here, where we're going to make a statement, and then to the right of that, there needs to be a column of the reasons why we can make those statements. Okay, we're going to start with given information that is given to us, and the knowledge that we have to make statements, to deduct our way down, to be able to say the statement that we want to prove and have a valid reason for saying that statement. Okay, so those are the gist. That's the gist of proving something using two-column proofs in geometry. All right, so let me get my pen out. So the first thing you want to do is look at given information. The first thing I see here is AB is equal to congruent to BC. So this AB is congruent to BC. I always like when I look at I go through my givens, before I even write them down, I like to show that they are congruent on the diagram that is usually given with the problem. If there is no diagram, then I draw one myself. Okay, so AB is congruent to BC. Another thing I see, let's change the ink color to green, is that BD is a median of AC. Now, I know that a median bisects the opposite side. So if BD is the median of AC, I know that D is going to bisect AC. Therefore, AD is congruent to DC. So I have that. Okay, so those are my two givens. I'm going to also write them out as a starting point for our statements and our proof. So let's start with number one. AB is congruent to BC. And why can I say that? Because it is given to me. So I'm going to go to number 2, and I'm going to say BD is a median of AB. Why can I say that? Well, again, is me. All right, and then I'm going to go to number 3. Well, what's number 3? Well, we made this conjecture here that AD is congruent to DC. So I'm going to write that down there as well. I'll change the end color to keep it consistent. So AD is congruent to BC. And I hope you're following along, writing this down with me. It will definitely help you out. Why can I say that? Well, the definition of a median tells me that. My reason can be the definition of. All right, and just like that, I'm on my way. I have one side, two sides. I need a third side. Well, I can also say over here, BD is obviously equal to itself, BD. So I'm going to write for BD is congruent to BD. And that, if you didn't know, is called a reflexive property. Reflective property. Alright, well, it looks like to me like I got my third side. So now I can make the statement, and I'll put this color in black. I can make the statement that indeed triangle ABD is in fact congruent to triangle CBD. And why can I say it's congruent? Well, because of number 1, number 3, and number 4, I can use the side-side postulate. Triangles are in fact congruent. Now, one thing I want to point out, just to keep clear. When we talked about labeling triangles, I said it was important the order of the letters. Notice how in the labeling of ABD, or triangle ABD and triangle CBD, that AB is in the same place as CD, and they are congruent. AB, CB. Notice how BD and BD are in the same place. BD is congruent to itself, BD. And then also AD and CD. Just another thing to keep in mind, that it is important the way you label your triangles when you're calling them congruent. And now one last thing. Before we finish, I said I was going to use CPCTC, which stands for corresponding parts of congruent triangles are congruent. So how would I use that in a proof? That's what we want to see, right? Well, let's assume that instead of it saying prove that these two triangles are congruent, instead of it saying that, let's say it's saying to prove that angle A is congruent to angle C. So it wants to know if these two angles are congruent. Well, let's find out. So we go through that whole proof, correct? I can't necessarily prove, actually I can't prove that angle A is congruent to angle C with the given information right here. I cannot directly prove that that is true. They look the same, but that's not valid. Okay? So, what I can do is go through the proof that we just went through to get to, I think it was that 5th step, to say that, in fact, triangle ABD is congruent to triangle CBD. And now, I know that I have two congruent triangles. Well, look at that. Angle A is in one of those triangles, and angle C is in the other triangle. Are they corresponding parts? Yes, they are. Why? Because they are in the same spot in the label. You can see that. That's a good way of telling that they are corresponding parts. Also, you can see that the short side goes into the long side, and then also the short side goes into the long side, and it is opposite of this hypotenuse right here. So we can say, yes, they're corresponding parts of congruent triangles. So I can say angle A is congruent to angle C because of CPCTC. Corresponding parts, angle A and angle C are corresponding, of congruent triangles. We just proved that these two are in fact congruent, are congruent. That's all I have for you for this lesson. Make sure you go try your homework. If you have any questions, feel free to contact me on BBIM, text message, or phone, whatever's easier for you. And make sure you come to live class. We can go through some more examples.